The purpose of this video is to give you an introduction of the different types of measurements we encounter in physics, both scalar and vector. Up until now, most of the measurements that you have taken in science class have been scalar measurements. Scalar measurements are those that just have a number associated with them, or sometimes we may say that they have only a magnitude or a size. For example, last semester you may have measured out masses of different objects. An object that has 10 grams of mass, that is a scalar measurement. In physics, the two basic scalar measurements that we will discuss are distance and speed. On the other hand, there's a whole other type of measurement out there called vector measurements. Vector measurements are those that have a size and a direction. So for example, if I kick a soccer ball, I apply a force with my foot, but that force also has a direction. I may kick the ball to the right or to the left. An example that's listed here is a car travels 12 kilometers northwest. It has both a size, kilometers, and a direction, northwest. In this unit of study in physics class, the two basic vector measurements that we will cover will be displacement and velocity. The main point of this video is really to discuss the first two measurements that we will encounter, and that's distance and displacement. Remember from the previous slide that distance is a scalar measurement. It only has a value, a magnitude. So for example, a distance is a total length of a trip. Think of this as the odometer reading in your car. You may want to add that to your notes, that the distance is the odometer reading. It doesn't matter what direction you drive in your car, the distance keeps adding up, the mileage keeps adding up. So that's the odometer reading. On the other hand though, displacement, this is the new idea that we'll talk about this semester. Displacement is how far away you've traveled from your starting position. Okay, so how far away you've traveled and in what direction you end up from your starting position. So displacement is a vector measurement while distance is a scalar measurement. Let's take a look at an example. Here we have two diagrams, A and B, both of a car traveling different legs of a journey. If we look at sample A first, sample A, and we look at what happens with the car travels 4 kilometers, it stops, and then travels an additional 2 kilometers. The total distance that has been traveled is 6 kilometers. That's the total odometer change that would have occurred in the car. Displacement is how far away and in what direction you end up compared to the starting point. So if you look at this car, the car has traveled a total of 6 kilometers to the right, or maybe it's to the east of its starting position. So the proper displacement would be 6 kilometers east. Notice that my displacement, because it's a vector measurement, has two components. It has a magnitude and a direction. You need to have both components in your displacement in order for it to be correct. Take a look at example B. Notice here the car travels 4 kilometers and stops, but now it turns around and travels 2 kilometers back in the direction that it came from. The distance traveled, again, would be 6 kilometers. It's the total length of the trip. The displacement, on the other hand, is different. Remember, the displacement is how far away do you end up from your starting position. And if we look at the front of the car starts here and it ends up here. The total displacement for this car is 2 kilometers to the east or to the right. Notice again that my displacement is telling me how far away and in what direction I end up compared to my starting position. Most of the time we won't have diagrams such as these, we'll have word problems. So let's take a look at a couple word problems, have these in your notes, and we can go through them a little bit more in class next time. Question 1 says a car drives 10 kilometers south, then turns around and drives 15 kilometers north. Sometimes it does help to draw a diagram of what's going on. So if I drew a diagram here that a car travels 10 kilometers south and then turns around and drives 15 kilometers north, the total distance traveled is 10 plus 15. It's the total length of the trip. So the distance traveled would be 25 kilometers. The displacement is how far away this object ends up compared to where it began. In this case, the object began here, travels south, and then back north. Notice it goes further north than where it began. So in this case, this object ends up 5 kilometers north of where it began. Let's take a look at one more problem for this video. A bunny hops 20 feet to the right, stops and nibbles some clover. It then hops 5 more feet to the right, sees a dog, and hops 30 feet to the left. What's the total distance traveled? Well, if we take a look at the total distance, it would be 20 plus 5 plus 30. So this bunny hopped a total of 55 feet. The displacement, it may help to do a diagram. So this bunny hopped 20 feet to the right. It stopped and then hopped 5 more to the right. And then it turned around and went in the opposite direction for 30 feet. If I look at where the rabbit began compared to where it ends, this rabbit ends up 5 feet to the left of where it began. Make sure you have notes to show in class, including the answers to these problems, and if you have any questions or comments, please bring those to class and we can discuss those next time.